Nurul Hazrina binti Nordin from UMTSA STEM Lab with the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to Chapter 2, Control Flow in Raspberry Pi of our Micro-Credential course on Raspberry Pi programming. This course involves integrating Python programming with hardware, specifically using Raspberry Pi system, Raspberry Pi 4, and microcontrollers like the Raspberry Pi Pico. Students will design and implement real-world projects that combine Python programming with hardware components such as sensors, actuators, and communication module. By the end of this module, students will be able to develop functional Python programming that interact with hardware for innovative solutions. In this section, we will build on the foundational skills introduced in Chapter 1 by exploring control flow, one of the core concepts in programming. Throughout this lesson, we will focus on these essential programming structures. Conditional statements that will allow decision-making, such as turning an LED on when a button is pressed. Loops, which automate repetitive tasks like a green LED. Digital input and output handling, enabling hardware interactions with buttons and LEDs. This module directly supports the overall learning outcome of this course, developing a functional Python programming using appropriate control structures. By the end of this chapter, you'll be able to write Python script that responds to user input, control external devices, and make logical decisions in real time. These skills are fundamental for digital making applications, such as implementing digital input-output using push buttons and LEDs. To control hardware, we use Raspberry Pi's GPIOs, digital outputs control components like LEDs, while digital inputs allow the Pi to read button presses. Proper setup is necessary to ensure safe and efficient operations. In handling digital input and output and making decisions using Python, control flow determines how a program executes instructions. Understanding this concept is crucial when working with digital inputs and outputs, as it allows your Raspberry Pi to make real-time decisions based on sensors data or user interaction. In programming, control flow is managed through three types of control statements, which are sequential, conditional, and iterative statements. Let's go through each one with a flowchart example. The first type of control statement is the sequential statement. This is the simplest form of program execution, where instructions run line by line from top to bottom in a predefined order. For example, consider turning on an LED, waiting for a second, then turning it off. The program follows a structured sequence without any decision-making or repetition. Sequential execution is the foundation of all programs, ensuring that each line of code is executed in the correct order. The second type is conditional statements, such as if-else, which allow decision-making within a program. This is where the program checks a condition before executing specific instructions. For example, if a button is pressed, turn on an LED, otherwise keep it off. Conditional logic is widely used in real-world applications, such as security systems, smart home automations, and sensor-driven responses, where actions depends on certain conditions being met. Conditional statements like these if-else help us make decisions in our code. If a button is pressed, we can turn on an LED. This technique is useful for interactive projects like the smart home automation system and automation. Learning to handle this effectively enables more complex interactions between hardware and software. The third control statement is the iterative statements or loops. Loops helps execute tasks repeatedly without needing to write the same code multiple times. For example, we use a loop to make an LED blink continuously, turning it on, waiting for a second, turning it off, and repeating the process. Loops are essential for automation and real-time systems like the traffic light controllers, sensor-based monitoring, and robotics, where tasks need to run continuously. Understanding these control structures, sequential, conditional, and iterative statements, is fundamental for writing efficient Python programming on Raspberry Pi. Understanding these control structures, sequential, conditional, and iterative statement is fundamental for writing efficient Python programs on Raspberry Pi. By applying these concepts, you can develop an interactive and automated system, enabling your Raspberry Pi to respond intelligently to users' input and sensor data. Now that we have covered control flow, let's move on to hands-on implementation. Now that we have covered the control flow, let's move on to the hands-on implementation, where we'll apply these concepts to control GPIO pins with Python. This is an example of a sequential statements in Python. Import the GPIO library and configure pin modes. Set the LED pin as an output and write a program to turn it on and off. This steps is foundation for more advanced applications like home automation and robotics. Let's see how this works in Python. This is where you import GPIO library and configure pin modes. And then you write a code to turn an LED on and off. Time interval of 1 second is being stated by time.sleep for 1 second. Conditional statement like if-else help us make decisions in our code. If a button is pressed, we can turn on an LED. This techniques is useful for interactive projects like the smart home system and automation system. Learning to handle inputs effectively enables more complex interactions between hardware and software. Loops help us execute tasks repeatedly. In this example, we will blink an LED in an infinite loop, making it turn on and off at 1 second intervals. Loops are essential for automation and real-time systems such as traffic light controllers and sensor-based alerts. Here's a step-by-step guide to program and write Raspberry Pi Pico to light up an LED on pin 14 using MicroPython. Here's a step-by-step guide to program and write a Raspberry Pi Pico to light up an LED on pin 14 when push button is pressed using MicroPython.